second loop, we have the equation R2 plus R3 plus R5 equals R6. And what that looks like is we have the R6 vector, and so theta 6 equals 0. We have our R2 vector right here, and as before, theta 2 is measured there. We have our theta 3 vector right there because that's R3, and then we have theta 5 is right there at the tail of our R5 vector. So we have our polar form of our equations is going to be R2 e to the I theta 2 plus R3 e to the I theta 3 plus R5 e to the I theta 5 equals R6 e to the I theta 6, because theta 6 is equal to 0, e to the I theta 6 is equal to 1. Now, as we look at our different types of vectors here, theta 5, theta 3, and theta 2 change, as does R6. Okay, and so that means we've got a type 2, type 2, type 2, and a type 3. Now, we also have theta 3 equals theta 4, and that means omega 3 equals omega 4. When we take the derivative of type 2 vector, we're going to get R2 omega 2 I e to the I theta 2 plus R3 omega 3 I e to the I theta 3 plus R5 omega 5 I e to the I theta 5 equals R6 dot. That means that we can, since we already know omega 2 and omega 3, means we're going to solve for omega 5 and R6 dot. Now, we can eliminate R6 dot from this equation fairly easily. We can just take the imaginary part. It's already a pure real. There's no e to the I term here because that was equal to 0. So if we take the imaginary part, then that's going to give us R2 omega 2 cosine theta 2 plus R3 omega 3 cosine theta 3 plus R5 omega 5 cosine theta 5 equals 0, and the only unknown in that equation is omega 5 because we will have already solved for the rest of it. So we can rearrange that and get omega 5 is equal to excuse me, minus R2 omega 2 cosine theta 2 plus, minus R3 omega 3 cosine theta 3, and all that's divided by R5 cosine theta 5. To solve for R6 dot, we could just plug in the numbers. We've got an expression there. We could take the real part, or and actually that might be the easiest route to go for this, but there are other ways you could do it. We can multiply by this equation by e to the minus I theta 5, and then that would give us R2 omega 2 I e to the I theta 2 minus theta 5 plus R3 omega 3 I e to the I theta 3 minus theta 5. And then we'll have plus R5 omega 5 I, and that's going to be equal to R6 dot e to the I minus theta 5. We can then, since the term we're trying to get rid of is imaginary, we can take the real part, and that will give us minus R2 omega 2 sine theta 2 minus theta 5 minus R3 omega 3 sine theta 3 minus theta 5. This term is going to go away, and that's going to be equal to R6 dot, and then that's going to be cosine of minus theta 5, which is the same as cosine of theta 5. We can then rearrange that and get R6 dot is equal to minus R2 omega 2 sine theta 2 minus theta 5 minus R3 omega 3 sine theta 3 minus theta 5, all divided by cosine. And since cosine of minus x is the same as cosine of x, I can just write that as theta 5. And so I have now equations for everything I need, which just means I just have to get measurements for everything, and I can solve the problem.